Oh, gotta have my favorite student. Who's my favorite student? Good old Anne. Suppose a forklift raises, this is the key idea here. If I'm raising or lifting, I am doing work, because which force am I doing work against? mg, gravity. So I won't tell you that in the question. How much work is done? In fact, it ends up being mgh, force, mg, times distance. It's going to be 688 times 9.8 times 2.4. Mr. Dewick, you didn't use that 45 seconds. I bet you I'll use it in part B. Come on, calculator, here we go. 688 times 9.8 times 2.4. You get, I'm going to go 16,200. Joules. Okay. 1 mark, all or nothing. How much power? Well, power is work over time. It's going to be 16181.76, 16181.76 divided by 45. I get 359.6. I'm going to go 359. Well, no, I guess 359 watts would be wrong. I'm going to go 360 watts if I round off properly. Because it's a 5 next to the 9, isn't there? Okay, 1 mark, all or nothing. What will I do? Okay. You know what? I forgot to do a check to see who was away. Pause. Continue. How much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? 0 joules. Because the force is carrying gravity, but the distance is forward. Okay. How much force does the motor exert? You know what, Alicia? I think now I'm gonna list my data. They've told me power, 65 kilowatts. I can go kilo in my head times 1,000. They gave me a distance, 17.5. It is lifts. They gave me a time. They want me to find a force. I think I know what to do. Power is work over time. Power is, what's another way to write work? Force times distance. Did you say force? Okay. So I want to get that by itself. I think I'm going to times the T. I think I'm going to divide the D. I think I'm going to get this. The force is going to be the power times the time divided by D. It's going to be the power, 65,000, times the time divided by 17.5. 65,000 times the time divided by 17.5. Oh, nice. 130,000? I'm going to go 1.3 times 10 to the 1, 2, 3, 4, 5. I could even have calculated the mass if I divided that by 9.8. That would tell me the mass, but they didn't ask for that. So if you got that, 2 out of 2. Otherwise, I would probably go something like this. Half mark if I saw that. Half mark if I saw that. Half mark if I saw that. and then a half mark for the answer. Cool. 4, a rifle can shoot a bullet. Find kinetic energy. Okay. Kinetic energy is a half mv squared. It's going to be 0.5. 4.2 grams is 0.0042. 965 meters per second squared is pretty fast. It's a high-powered rifle. I'm going to go 1,960. 1,960 joules. Okay. John, what does B want me to find? Oh, work equals force times distance. Oh, did they give me a force in newtons in this question, John? And I'm not lifting, so I can't assume mg. Did they give me a distance in this question, John? Can't use that. Oh, work is also the area under a force versus distance graph. Did they give me a force versus distance graph? This is the checklist now. Whenever I see the question, how much work? Then I move to my third definition, which was change in potential plus change in kinetic. Connor, I don't think this question is implying that there's any kind of a change in height. I think I can do that. So it's going to be final minus initial. Oh, wait a minute. It said it starts from rest. Oh, and you know what KE final is? (1,960) joules of work was done on the bullet. Why? Because the bullet started out with no energy, and that's how much energy it has now. If the work is done over a distance of 0.75 meters, what's the average force on the bullet? Well, work equals force times distance, so I guess force is going to be work divided by distance. It's going to be 1,960 divided by 0.75, although I'm going to use my exact value now, divided by 0.75, and I get, you get 2,610 newtons? You back? Okay. Where were you? Never mind. Just not here, we're pretty sure. A asks, what's the potential energy? Potential energy is mgh. 50 times 9.8 times 400. That's what 4 times 10 to the second is. 50 times 9.8 times 400. 196,000, is that right? 196,000 joules, or 1.96 times 10 to the 5th joules. Alex, what does part B want me to find? What's change in anything? Oh, okay. The final potential energy is going to be mgh final minus the initial potential energy is 196,000. This is the long way to do it. The short way to do it is to notice it's at half the height. I think it's going to have half the energy. But anyways, it's going to be, we'll do it the long way, 50 times 9.8 times 200 minus 196,000. Do you get negative 98,000? What's the negative saying? You lost energy. I would live with Lindsay if you said positive 98,000 joules of energy lost. I'd say that too. And then I'd turn the page. Find the kinetic energy of the bike and rider. Well, kinetic energy equals a half mv squared, 0.5, 85, 8.5 squared. And I'll go 3,070. Again, you could go 3,070.625. You go 3,071. The rider coasts up the hill. Assuming there is no friction, at what height will the bike come to a stop? Well, you can do this the long way, conservation of energy. There's a change in height, change in speed, yucky curvy path. So you could say, well, kinetic initial plus potential initial equals kinetic final plus potential final. Or, Prith, if you were really wrapping your brain around this, you could say, you know what? All of my initial kinetic is going to turn into potential because at the top I'm at rest and I'm starting on the ground, and so enough to start right on that line. It's what I would have done if I was in a rush. And I'll get mgh equals 3,070. How would I get the h by itself? H is going to be 1,070 divided by m g. It's going to be this number divided by 85 times 9.8. And I get, do you get 3.7 meters? Yeah. Suppose an object is traveling at 10 meters per second. What happens to its kinetic energy if we double its velocity? 4 times larger. What if we triple its velocity? 9 times larger. Suppose a toy car is at the top of the ramp. Neglecting friction, how much energy will it have, how much kinetic energy will it have when it reaches the bottom of the ramp, and what will its speed be? Okay. I'm going to call this kind of a part A, and I'll call this part B. Part A, this is a change in height, change in speed, yucky curvy path. I think in this question, the final potential at the bottom is 0, and I think you're starting out at rest. How do I know? Because it doesn't say we're starting out with speed. I'm going to get mgh initial. That equals the kinetic energy final. And that's all this wants me to find for part A. So kinetic energy final is going to be mgh. 78.89? Joules. That gets you 1 mark. Then it wants me to get the speed. Okay, Ke equals a half mv squared. Prith, how would I get the v by itself? So it's going to be 2 times 78.89 all over 3.5. Don't forget to square root. 2 times that answer all over 3.5. Don't forget to square root. 6.7? 6.71. I'll go 6.7 meters per second. I would probably give you 1 mark if I saw that, and then 1 mark for the answer, and there's your 3 marks. Could you give yourself, please, a lovely score out of 16 on take-home quiz number 2? And if you need to lawyer with me, now is the time. Questions from the homework, lesson 6, number 9. This one here, rocket car? Oh, cool, rocket car. All right. What does it want me to find? What did they give me in this question? A force versus distance graph. You know what? I'm going to figure out how fast by using work. I'm going to figure out how fast this rocket car is going. I like this question. You know what? I haven't looked at the test. I'm looking at it this weekend. I think I like this question. Okay. I'm going to write this, Sarah. Work equals the change in potential plus the change in kinetic. It does say level ground, so I'm going to yoink. Why did I write that? Well, kinetic does contain V's. Yes? And they gave me a force versus distance graph that suggests work. Hey, that's the equation that has both. Accelerates from rest. So what's your initial kinetic energy? So really I end up with this. Work equals a half mv final squared. You okay with that? How would I get the v by itself? Times by 2, divide by m, and then square root. Okay? So I'm going to get this. The final speed is going to be 2 times the work divided by the mass. Square root. The real question is, what's going to go next to the 2? What's the work? Well, it's going to be that area, which I'm going to break into a rectangle and a little triangle. Is that okay, Sarah? Think you can take it from here, or do you want me to keep going?
Yeah,
Okay, so it's going to be the bottom one, length 10, width 50. And then the top one is a triangle, which is going to be base times height divided by 2. 10 times 10 divided by 2. And I'll add them up, and that's what's going to go in the little blank there. I think so. And hopefully I didn't make a mistake on this answer key, but who knows? I was doing these in a rush. Is that okay? Yeah. Yeah. For 8? That's why it's nasty. 8a, what does it want me to find?
Work done by friction.
You know what? That's a synonym for heat. Is there a change in height?
Yes.
Is there a change in speed? Okay. I'm going to use conservation of energy, G. I know it says work, but I've learned when it says work done by friction, really let me find the heat. So I'm going to go like this for part A. KE initial plus PE initial equals KE final plus PE final plus heat. Now, for me right now, final is right there. And I think I'm going to assume you started out vertically at rest. Oh, it does say VI equals 0. Yay! And I'm going to say the ground is 0. Okay. Do you think you could use that to find heat? Okay, I'll let you try that. Part B. Find the work done by the snow during the impact. Okay, this isn't heat. This is the work done by the snow during the impact. Well, now I might try okay. Would I try that, Mr. Duick? And so I would here's your hint, take the ground level to be h equals 0. That's how much energy he hits the ground with. Where does that energy go? I think it's absorbed by the snow. So I would calculate how much energy he has, how much energy he hits the ground with. Okay, I think that'll get you there. And then once you have that, part C, find the average force of the snow. You'll use work equals force times distance. So the average force will be the work done by the snow, done by the distance of the snow. How deep is the snow? 1.15 meters. I think that'll get you there. Okay? I hope. I'm a little leery on the middle part. I have to run some numbers to see if I'm doing it right. I think. And that, yeah, okay. I think what you'll find is how much energy he hits the ground with, and that's why I said technically negative, because the snow is bleeding off the energy when the paratrooper hits the ground. Is that all right? That's a nasty. Any others? You with me, Alex? I have 2 things for you today, another take-home quiz and a review. The review is due the day of the test, which is a week from today. Take-home quiz is due next class.